I don't think I tried making a video of this to explain the plastic bridge pins for a Martin. And I'm going to explain why these are superior, actually, and why they're so soft. So you have a larger diameter at the initial taper. It's the same taper they explained to me, but the diameters are different from the top of the bridge to the base of the bridge plate. And so what that means is that you have three different woods here. You have their spruce, you have your ebony, and maple, and they don't expand and contract the same way. Now, Martin didn't explain this to me. This is just my own analysis. But this guitar is a fresh Martin, and generically so. If you stress a guitar as much as I have in humidity level, this has gone way down and it's gone way up in humidity since I've owned it. And why I believe that I can do that without as much fear is one, this is modeled after their museum piece, which the old pre-wars don't have a lot of cracked tops. And without an adjustable truss rod, so this doesn't actually maintain a consistent tension. It's not setting parameters in the truss rod. If you know how truss rods work, it's a metal bar with a big pole in it, and then that tightens and loosens, and that creates a bow. Well, that metal bar, because of that, can only flex so far and expand so far. And so that maintains a more consistent string tension, like I've mentioned in other videos. But that maintains a consistent tension to the top as well. So you're stressing the top. And as the top shrinks, what's going to happen? It's going to crack. Well, also, you have three woods here that these tapers are going to be changing differently. So whether or not Martin or, the old pre-wars were all sort of built by their own luthiers. They were built to specs, but they were all kind of a little different, left to their own ingenuity in a way. And whether or not it was calculated how the ebony will change versus the spruce versus the maple, and that decided the taper. But in case that doesn't happen, if I had bone in here, as the wood shrinks, if you don't have a constant humidity level, what do you think is going to happen? It's going to apply pressure to a non-restricting or a non-compressive medium, and the bone is going to apply outwardly on a shrinking medium. So these actually compressed and started shrinking. I was like, oh, these things are garbage. What the And I'm like, I better not change them though. I want to understand them thoroughly before I get something better and really might make a bad mistake. So if you have consistent humidity levels, yeah, get bone. But if you have plastic and you don't humidify your Martin, keep these. Not only do they flex around the ball of the string, which then applies an upward force to the top because it hooks under the bridge plate, and then the ball joint hooks under the bridge plate to the front of the bridge pin and the slot and everything, so everything's sort of pulling up. That physics is awesome too. So these really have a multifaceted philosophy of mine, an engineering and system that makes them superior. Just because they're softer doesn't mean that they're bad. They're actually keeping your top from shrinking. Now, this all goes into like the see, because you got pitched the radius, the back's a radius, but that's like a leaf spring, and that's a counter leaf spring system with the top and the bracing and everything. It's all engineered and designed extremely well. But this is all from an era where we basically mastered leaf springs, and those are very funny and kind of complicated in their own right. They're counterintuitive to anybody in a modern age. So why people love coiled springs, but leaf springs are the smoothest. And so that's why these sound so good, and why you should keep these plastic bridge pins, because they are going to help prevent your tops from cracking. And of course, it's made with hide glue too, so hide glue doesn't creep. Creeping allows for different grain fibers in the glue joint to be stressed based on how the wood is imperfect, I want to say. The grain is not a consistent density, so how it shrinks and expands can be different. And while this guitar, I suppose, is made with the best of the best at the options for the custom shop or for the authentics, a regular, more mass-produced guitar, that they're not going into the best of the best. Because, I mean, this thing, I will touch my guitar case and you'll hear it. Like, I'll just touch it and it'll go boom. It just start resonating. It's unbelievable. And so maybe they did some magic with calculating how the humidity would change, or just simply copying the old design just happened to work for this guitar explicitly. I doubt that. I mean, I really doubt that. So there's got to be some sort of engineering and thought and calculation done into this to keep it functioning as it was without as much necessity. Because in the 30s, they didn't really have humidifiers, did they? And I doubt Martin was planning on keeping these in Tennessee where it's really humid, or bringing them down. And then they were designed, for traveling musicians too, that if you're going to come to Colorado, think about, didn't John Denver play at E45s? Maybe D28, right? Or you got Johnny Cash, and so his guitar was experiencing stress all the time. But you never saw a crack in the top of his guitar, did you? Maybe he humidified, I don't know. But throughout history, I doubt every single Martin, the old ones, were humidified, and you rarely see them with top cracks.